So, we're going to talk about sustainable development, LEED certification, green buildings, whatever you want to call it. We're going to go through this quick. We've got 45 minutes to cover 3 hours of material. So, if you're ready, I'm ready. Let's roll. 44 minutes now. All right, and don't forget, if you want the checklist or the Excel spreadsheets, just write spreadsheet, checklist on your business card, bring it up, I'll email it to you probably before you get home. I'll do it tomorrow morning when I'm sitting in my room. So if you want it, great. If you don't, no big deal, but you can have it. So where were you on April 22nd, 1970? And when I asked this question, the normal answer is I wasn't born yet. So if you're not sitting in the very last row of this room, just to the right of the doorway, 1970. How many of you were not born? You disgust me. All right, we're done. Yeah, we're done. We're going to go drink now.
I was 3 years old.
You were 3 years old. Okay, Luis, you're in the club. 1970. Yeah, we were almost in college by then. This is Senator Gaylord Nelson. April 22nd, 1970, giving a speech in Denver, Colorado. What do you think the significance of that date is? Anybody know? The significance of April 22nd. Still celebrated today.
Earth Day.
Earth Day. So I remember Earth Day when we were kids. Well, I wasn't a real kid in 70. I was almost an adult. And we'd go out and do newspaper drives, can drives, all kinds of things. Earth Day. And the history of that is, there's a little bit of significance, but it was basically the start of the EPA. So in 1970, in December, just 7 months later, the federal government created an agency which still exists today, the EPA, based on the speech and the creation of Earth Day. So if you haven't heard about green buildings, I'm imagining you've been under a rock somewhere. A quick history lesson. I've showed you this. I think this information is in your material. I don't need to go through every one of these dates, but basically Earth Day led to the EPA, which led to the DEQ, which led to what we now have is Environmental Sustainable Design and Development, LEED certification, a couple of others that we refer to, Green Globes as well. But in the LEED is what we know most often. That's what we refer to. So just some quick statistics. This is buildings. Now this information comes from the U.S. GBC, United States Green Building Council, which is the organization that provides the LEED certifications you see on buildings today. 12% of water, 39% CO2, 65% waste, 71% electric is all impacted by U.S. buildings. This is all U.S. buildings, not just industrial office that we're concerned with, but residential as well. Building operations contribute to 71% of the national energy electric consumption. Industry is only 27%, a little shocking there. Buildings consume total energy, 39%, 40% of the international total. The one thing about statistics, and you may want to know this, that's fascinating and also factual, is that 37.4, not 37.4, 37.4%, you writing this down? Of all statistics are made up on the spot. So, you guys are great. Write that down. That will be on the test? No, it's not. Okay, so global emissions by sector, building clearly number one in CO2 emissions. Basically, a green building is a building that provides an opportunity to practice increasing efficiency of how we use our natural resources through the design, siting, and operation of a building. Why build green? Well, I think we could answer that easily. Environmental benefits, we want to enhance and protect the biodiversity system, improve air and water quality. I don't think anybody could argue any of these points. Reduce waste and conserve and restore natural resources. But one thing that I think you're going to find is, everybody in the room except Luis raised his hand, or her hand, that weren't born in 1970. You're of a generation of a different level of consciousness. And I think that your generation sees the world from a totally different perspective than my generation, and especially in a much different way than the generation before mine. where the generation before us was the build generation. We're making everything. Our generation has been a little bit more the accumulation generation. Your generation has a more tendency to be socially conscious and aware of what the future might hold. For example, making decisions on what you buy based on how it was made. Right? I see that. My children are 25 and 27 years old, and I know that they think about things before they just go onto Amazon and buy stuff. It's like, well, where did that come from? How was that made? What's the products that go behind it? How are they polluting the world? But, you know, I never thought of that. I just went down to the store and bought what I wanted. Economic benefits. Obviously, there's a reduction in operating costs. Creation and expansion of markets for green industry. And that's huge. I mean, one of the things we talked about just a little while ago, LED lighting. 5 years ago, was there a market for LED lighting? No. But there's been a demand for more efficient lighting products. LED comes on the market. It's initially more expensive, but it's going to gradually offset that through energy conservation. I mean, you put an LED light bulb in it, it lasts as long as fruitcakes. So, improve occupant productivity. I'm going to tell you some statistics about that in a little bit. Retaining tenants, optimizing life cycle, and one of the most important things that we talked about early on was creating and designing buildings that avoid future functional and economic obsolescence. So we're giving advice and guidance to our customers, again providing what? Great information so they can make good decisions, including decisions on sustainability. Social benefits, enhance the occupant's comfort and health. Indoor air quality is a huge topic of conversation. Natural lighting is a huge topic of conversation. Heightened aesthetic qualities. Minimizing the strain on local infrastructure, and just basically improving the overall quality of our life. Interesting statistic that on average 90% of the time people spend is indoors in the United States. 90% of our day is inside. Green buildings typically have better indoor air quality and better lighting, creating a better work environment, living environment, more healthy environment for all of us. Walmart found that stores they had with natural lighting, especially skylighting, had a 40% increase in sales over stores that did not. So there's a direct correlation with how you feel to how you spend. Herman Miller showed that they paid for their daylighting in 2 years through worker effectiveness. They measure the effectiveness of their workers, the production flow, and so forth. Productivity increased enough to offset the cost of improving daylight quality in their manufacturing facilities and their headquarters office. It paid for itself in 2 years. The Mahone Group said that workers in their call centers process calls 6 to 12% faster when they had a view outside, looking outside. So in this particular room, imagine this was your office, and we closed that drape where Bob's sitting, and there was no connectivity to the outside. Would your productivity be very high on a regular basis? It'd be pretty depressing, wouldn't it? Yeah, I would think so. More so if you had to listen to me every day, dude. Attract and retain tenants. I think this is a great one. Turnover dropped 50% below the typical level at a PNC by attracting and retaining the employees that work for your company. So a great benefit to a tenant employee turnover. Insurance costs. Fireman's Fund says that they're giving a 5% discount for companies who are occupying buildings with a LEED certification. Why go green? Go green. Obviously, we're going to lower these costs and opportunity to save the environment. 63% of large corporate CEOs say that green building is an opportunity for market differentiation. I think this is huge, and especially as decision makers are getting younger. That market differentiation, to be able to say that we are a green company when you're selling motor cars. For example, Honda Motor Company built a sales and service center in Portland, Oregon 12 years ago. Pretty far ahead of the environmental curve, I would say. But they spent about 15% premium on their building to go green, because the Toyota Motor Company wanted to tell their customers that even though we're selling, our product consumes gasoline, we're doing everything we can to be environmentally sustainable. So it was all natural lighting, it was natural ventilation, it was recycled materials. It was an incredible exhibit on their part to demonstrate their willingness to go the extra mile for a single reason. And I don't think it had anything to do with the fact that the owners of Toyota Motor Company had a social consciousness. I think it had everything to do with the marketing department saying, we need to do something to differentiate ourselves in our industry. Aspects of the green building. These are the components that the Green Building Council looks at in scoring a project: siding, design, construction, operation, maintenance, renovation, and then deconstruction. Obviously, we're trying to save consumption in water, energy, materials, natural resources. This is called a light pollution. When you see actual lighting escaping the bounds of which it was intended. So let me give you an example. In Portland, we had a project where we had a company manufacturing trailers, utility trailers for the military. So these were really cool, high-end trailers that were being stored outdoors. Obviously, these are heavy-duty trailers that go on the back of a Humvee and whatever for combat. Well, they build the trailers inside, they store them outside, but military restrictions, military requirements say that the outside storage yard has to be secure, has to be paved, and has to be lighted. So this particular building is adjacent to, remember I talked about the slough, which is a man-made waterway for just stormwater drainage, basically? The property is adjacent to this slough, which over time has become home to critters. So the City of Portland's Planning Department, Bureau of Environmental Services, BES, in their infinite wisdom says, we're going to create a 50-foot no-touch zone adjacent to the slough. Well, right away, every building in this particular industrial area is in violation because they're all closer to that 50 feet than is being restricted. But they're saying now that any building permit you go in for going forward is going to be subject to this new set of guidelines and this 50-foot no-touch zone. Well, the yard is already up to about 20 feet from the top of the bank of the slough. It's there. It's been there for 50 years. It's paved, it's fenced, and we needed to add lighting to meet the military requirements for this particular use of the property. So I've got this functional requirement, I've got a military requirement that I have to light the site, and I've got Bureau of Environmental Services telling me I can't create light pollution for the critters that live in the slough. Okay? So that means I can't put a typical wall pack lighting unit on the side of my building and shine light out into my fenced yard, because that will escape the bounds of the yard and light up the slough at night, and whoever lives there, if it's the light's there, it's going to screw up their ecosystem. Okay, well, let's just go put a light standard at the edge of the property and shine it back against the building. Well, sorry, you can't do that because your light standard is now inside of that 50-foot no-touch zone. So you don't get a permit to put a light standard up within 50 feet of the slough. You can't put a light up on the outside of your building to shine out because you're going to pollute the light or pollute the stream with the light. So what do I do? Well, it took us to actually have the mayor come out and look at this and see how insane this situation was. And he says, just build your light standards. Let's shine the light away from the slough. I think everybody will be happy. You're building it on a paved fence yard that's already there. It's not like we're disturbing the ecosystem by putting these light standards in. But you got a bureaucrat sitting in office writing rules, and he's reacting to a proposal based on the rules they've written without ever having gone out and seen the market. Be aware. Energy Star is a government program. The USGBC, by the way, is that a government program? Private? The United States Green Building Extortion Council. The USGBC is a private entity that's created its own set of rules, its own fee structure to be certified with a LEED certification. Energy Star is a DEQ, Department of Environmental Quality program, and EPA, which basically creates a platform by which you must live by in how you consume energy. Why the increase in demand? Well, we talked about that. Unprecedented levels of government initiatives, basically zoning codes today. The UBC, Uniform Building Code, is building buildings to LEED certification. Okay? Let me give you another example. The 500,000-foot building we're doing for SPACT in Portland and every other building under construction in Portland is not going for LEED certification. It is not. Because we can't afford to. There is no way to get an industrial building LEED certified going forward today. It's just not going to happen. It's crazy. So they've kind of priced themselves out of the market of LEED certification. None of these developers are doing it. 3-4 years ago, everybody was doing it. Yes, question.
They're doing it, yeah.
They are? Who?
Pantone.
Panattoni?
And, Prudential.
Yeah.
Actually, it's not Prudential, but it's Spec.
Yeah, include,
We're doing on spec more for the marketing purposes.
yeah, all of these buildings I'm talking about are speculative buildings. Every one of them. Prologis, IPT, McMorgan, New York Life, my client spec, Holland Development, Trammell Crow, major players in our world. None of them are going for LEED certification. David?
Sometimes we say meets.
Yeah.
Meets requirements.
You can say, we're saying that we are building our building to sustainable standards. Okay? Part of the problem with the LEED certification is just the application cost itself is pretty crazy. But the point system has evolved to where if you simply build to the Uniform Building Code today, you're building a LEED certified building. You're building a building that was LEED certified a few years ago. They keep pushing the goalpost further and further out because their system is designed that you have to exceed basic standards to get the certification. It makes no sense. Green Globes, on the other hand, is another organization which recently achieved GSA approval. So Green Globes is a different system. If you want to know more about Green Globes, look them up. They happen to be a Portland-based company, but they're doing good things. So operational cost savings, higher level of corporate awareness, we talked about that, improved, affordable, sustainable materials, consumer expectations. Basically, it's also just simply the right way to go. I don't think any of the developers I'm talking about are arguing that they don't want to build a sustainable building. It certainly is the right way to go. The problem is with the certification. So this is the USGBC LEED rating system for new construction, existing buildings on operation and maintenance, commercial interiors, core and shell. 4 levels, right? LEED, LEED Silver, LEED Gold, LEED Platinum. Let me give you a little bit of an example of an office building differentiated from an industrial building. You get LEED points for doing reflective roof material. And let's say I'm building a 300,000 square foot office building that's built on a city block in downtown, whatever. What's the footprint of that building? Typically going to be about 20,000 square feet. What's the footprint of the 300,000 foot industrial building? 300,000. What if my premium is 15% to go to a reflective roof? Well, I can live pretty well on a 50% increase on a 20,000 foot roof. I'm having a hard time paying a 15% increase on a 300,000 square foot roof. That's what I'm talking about, why industrial developers are struggling really hard right now with getting the certification. No argument with building a sustainable building, big argument with paying the USGBC to get the certification. Point system, I put the scoreboard up at Wrigley Field. They're keeping score, and again, the score is based on how far you exceed the standards in your market. Washington, D.C. National Stadium, one of the things they did, one of the ways you can get LEED points is valet bike parking. So if you ride your bike to a ball game at National Stadium, they have valet bike parking. True story, yeah. I don't know what they charge for that, but I'm sure they charge for it. But they got LEED certification points for doing that. People, environment, economics. I want to move forward because I have a couple of creating and preserving value. Obviously, we talked about that. Lower cap rates. Achieving top market rents. You guys are all brokers. You're leasing space. You're representing tenants. Will a tenant in your market pay more for a LEED certified building or a sustainable building than not? Especially office brokers. Bridget?
I don't think in our market, we've had such devastation on the office side, I don't think people really care. But from a cap rate standpoint, yeah, if you lower expenses, you increase your NOI, then,
Okay.
Obviously.
So you're adding value by just by doing
By
it.
doing it, yeah. So that makes a little
Okay.
sense. Will the tenants pay a little bit more? Maybe. I don't know.
Yeah. I mean, I'm hearing stories from office brokers around the country that say that if you're not LEED certified, that you're probably not going to be able to call yourself Class A. So all of a sudden, your owner is going to go, holy cow, I built this great building, but I'm not Class A. I don't know, might be coming. Ryan, did you have a thought?
No, they wouldn't pay for it industrial.
No, I don't think so. But industrial companies sometimes, like we talked about Honda, love that market differentiation. So is it about the cost? I don't think so. I think it's about the value. So I've got a couple of case studies I want to go through, and then we're going to have questions if you have any. And as most classes do by the time we hit 6 o'clock, have none, because you want to go have a party. So that's what we're going to do. But I'm going to go through a couple of quick case studies. The first one is Coffee Bean International. This was a conversion of an old glass company, Owens Corning warehouse that was just not a good-looking building, into their corporate headquarters. Project purpose and use, primary functional objectives. I mean, we have to basically, to create the sustainable development concept and to achieve the LEED certification, you have to have a very clear plan. You've all heard the phrase LEED AP, accredited professional. So part of the reason one of the ways you get that LEED certification is by engaging a LEED accredited professional, LEED AP. So the LEED AP has to create the vision to submit to the USGBC for approval before you start your project. So you have to start with a big picture and assess your goals, establish your goals. Is that, again, we talked about this from the concrete apron standpoint. Long-term ownership versus merchant builder. What's your intent? How are you creating wealth through real estate? Am I creating a quick return, or am I long-term wealth creation? It's going to determine a lot about how we advise our customers on how to spend their money. Project schedule. Site and building program requirements, relationship between the types of rooms and the spaces required, everything from aesthetics to scale to mass to materials, reusing materials, all goes into the project goal-setting process. Developing costs for both conventional and sustainable approaches so that you can educate your client on the premium. What's the value? Not the cost, but the value. There's an increased cost. There's a premium for everything we're going to talk about, but what's the value you're creating? Am I going to have a better space for my employees? Am I going to have higher productivity? Am I going to have less turnover? Am I going to attract talented people? All of those questions come into play. Payback analysis. Aligning your goals with the sustainable practices to develop this plan that's submitted to the USGBC. So, alternative transportation and a water reduction plan for this building. This is the finished result. That whole facade that you see in front of you was once just a blank wall. So the project involved turning this just dreary warehouse into a corporate headquarters coffee roasting facility for CBI. One of the things they did was they created an optimized energy performance lighting and HVAC. So to do that, they installed a tremendous amount of natural ventilation. Now in some climates that's not as available. Las Vegas, I'm thinking you're not going to cool your buildings very conveniently by opening windows. No. But in Portland, a lot of the months out of the year, you can create a tremendous amount of fresh air and circulation by natural ventilation. Huge points for that. Lighting, obviously, having systems where lighting naturally goes off under a timer or a motion sensor, right? You walk into the room, lighting goes off, you set it to go, lighting goes on, you walk out of the room, a few minutes later, the lights go off. Also, a sensing system that says when I have a certain amount of natural light coming into my space, there's a sensor that either dims or turns off the interior lighting system. It might turn every other fixture off in a space because you have enough natural light to provide the minimum levels which you establish. Building was under a long-term lease. We had construction waste management. Here's another great example of how we can create LEED certification points. And what do you do with the waste materials of a project? In this case, there was a lot of demolition. So we used the aggregate that was cut up. When we cut new windows in these concrete walls, we ground that up, and that became the aggregate for the concrete that we needed to pour back on the site. So it was recycled right back onto the same site. The office building across the street from my office downtown that's under construction, the 30-story building, that building, the block that building is going up on a few years ago housed 6 different buildings, multi-leveled, everything from 4 to about 8 stories of old poured-in-place concrete type buildings. all that concrete and steel was ground up and is back into the new building now as new material. Pretty cool. IAQ, we talked about that, indoor air quality. That's a huge factor in creating environmentally positive spaces, desirable spaces for our tenants to occupy. Indoor air quality. It's versus natural ventilation versus mechanical cooling. Tremendous opportunity to create points for LEED certification. We talked about daylighting and views. This next project is the Clackamas County building, and it achieved LEED Silver. This is a government building developed by a private developer, happened to be Greg Speck, the same guy that I represented in several projects. And this was on a site that was a brownfield. So we had brownfield redevelopment. Everybody know what a brownfield is? Anybody not? Environmentally contaminated site. Okay? So we had to take a site that was basically out of circulation, off the market, go through a remediation plan and figure out what level of work needed to be done to create a buildable site void of environmental contamination. Okay? That's a brownfield. And big points for that because you're taking a site that's basically sitting fallow in your market, doing nothing, not producing revenue, not paying taxes, not creating any environmental contribution whatsoever, and you're returning it back to the world. So you get some points for that. Alternative transportation. Portland is known as the light rail capital of the world. We have tremendous leadership, I think, in our transportation system. Basically, it's a great opportunity for the homeless to get out of the weather. It hasn't taken anybody off of our freeways or roads, but I kid, kind of. Reduce site disturbance. So when you're building a project and you're next to an environmental sensitive area, like a slough, a wetland, a marshland, or something like that, you know, instead of coming in with trucks that just kind of go everywhere and do whatever they want, you create a plan that minimizes the impact on the surrounding part of your property. Heat island. Everybody know what a heat island is? Somebody's got to know what that is. You've heard that phrase before, heat island? Yeah, go ahead.
It's an area that generates more heat, like a parking lot.
Okay. Yeah. So basically, it's an area of your property that is absorbing heat from the sun during the day and radiating it back at night. It's a heat island. So in some cases, it's positive. In some cases, it's negative, and you can control that. If you want to use that heat in a productive manner, you can. Water efficient landscaping. Once again, we create systems that retain the rainwater off of the roofs. It goes into a cistern and then is then used to irrigate the landscaping. It can also be used for wastewater. You can use rainwater as gray water. Energy, natural lighting, fundamental building system commissioning. So in this case, you can see we've got some shading devices on the building that reflect the sun at certain angles. We want to maximize penetration during the winter, minimize penetration during the summer. And I'm going to show you a really cool example of that in just a few minutes. Checking a box on your power bill. You ever seen that? You got that in your market? You get your statement from your power company that says, would you like to receive green power? Anybody get that?
Yeah, for an extra $15.
Yeah, you pay a premium, right? So you pay a premium to help the power companies produce manufacturing facilities that, or whatever type of source they can, to get away from environmentally harmful methods of creating electricity. Wind, solar, etc. Right? You can check the box. I don't think that the wires actually know where the power is coming from that come to your building, but you're helping the power company do that.
That's marketing.
That's marketing, exactly. Storage and collection of recyclables, we talked about that. Building reuse. Certified wood. Anybody heard of certified wood? It's another cool phrase. What does that mean to you, Jeff?
That's farm sustainably.
Okay. So the whole concept of where the wood came from, how it was harvested, the mill that cut it into measurable, lumber, right? All of that goes into play into being certified by the USGBC. We talked about indoor air quality, big event, daylighting. So we had innovative strategies, a LEED accredited professional. One of the things that you do to get LEED certification points, which is kind of cool actually, is you develop a documentary film about the project itself that then goes onto a DVD and sits in somebody's drawer for the rest of their life. But you got LEED certification points for doing it. Not that I'm cynical. So, here's what happened on this particular building. This is a financial analysis, speculative, because you're looking into the future of what might happen based on the things you did to the building. So the annual baseline energy costs of $190,000, $1.75. Annual energy savings by the sustainable methodology we put into this building, we estimate at 35%. So a 5-year savings at that number, 300 grand. Appreciated value based on a 7 cap of that savings. Bridget, we talked about that. Guess what? You lower your operating costs, you own an office building. Where does that differential go? NOI. Wow. I'm doing energy efficient building. It's costing me a premium, but I'm increasing my NOI by a 35% margin on operating cost savings. Capitalize that at 7%. I got a $953,000 increased value. So my cost of my LEED certification was $719. Here's the 5-year savings. Here's the appreciated value. Net value gained over that investment, 79% at year 5. We figured about 16% annualized return on that investment. So you go to your owner, your client, say, would you invest $720,000 of a premium price to build this building if I could guarantee you 16% return on your investment? Most of my clients would say, that's a pretty good return on my investment. I'm going to do that. Plus, now what are you doing? Besides the financial rewards, what?
Differentiate.
Market differentiation. I've got a LEED building. I'm getting better tenants. I'm holding my tenants longer. There's access to capital in markets that will only fund sustainable buildings. They're out there. There's real estate funds that will only loan on sustainable buildings. So there's access to capital. There's increased NOI. There's increased tenant satisfaction. This is the next one I want to talk about. This is a River East Center. This is what it used to look like. This was a warehouse building, multi-level, 4-story warehouse, dock doors. This door was a rail siding, went into the building, so you had loading off the side of that. A few offices up here, but mostly just a big concrete bomber warehouse. Okay? This is what it looks like today. This is the same opening right there. This is the entry. They actually replicated some of the same look as the main entry of the building. So to sustainable site strategies, to build their plan to get LEED certification, here are some of the things that they did. Obviously using a LEED AP professional. This building, by the way, is owned and occupied by an architectural engineering company. So they were really into this. Not only was this going to be their new home, but this was their showroom for their future customers. So it's pretty cool. They had multi-dimensional motives on why to do this. Not only were these guys architects by nature, are kind of socially conscious. That's what they are. They're always thinking of ways to improve the environment and build better buildings and do things that are more efficient. That's just what they do. But in this case, it's also how can I show my future customers how great I am. So there was market differentiation in making an advertisement out of their own building. Brownfield real development. This is right along the Willamette River, across the river from downtown Portland, in an old industrial area where there's lots of contamination. We are on a bus line and light rail line in this area, so alternative transportation, stormwater management, heat island effect, light pollution reduction. You can see bike racking right here. Here we have an area that's architecturally kind of cool. This is collecting rainwater off the roof and then running it down to an area that's going to go directly into the property's landscape system. So we're taking rainwater, not letting it go into the stormwater system. We're putting it out into the landscape where it's going to percolate and naturally find its way into the water table naturally. Okay? So one of the cool things here is we're going to talk about is this light wall. This is a wall, and we've talked about most of these things already. So this wall is pretty cool. So you can see that they built this wall, which is basically a double layer of glass with shading devices. Again, the sun has different angles depending on the time of year, doesn't it? It's higher in the sky in the summer. It's lower in the sky in the winter. So we want to maximize penetration when we want to use the sun for natural heating. We want to minimize presentation when we want to try to keep the building cooler. So we've designed these shading devices to mostly address the angle of the sun. The other thing you see in this picture are what? Trees. But what kind of trees?
Green deciduous.
Deciduous trees. And deciduous trees do what?
Lose their leaf.
Very good.
Harvest sunshine.
So again, now we're creating shading in the summer with the leaves on the trees, solar penetration in the winter when the leaves are off the trees. Pretty smart. Okay? So here's how this solar wall works. Here you can see, here's the edge of the building. This is concrete. There's the old concrete columns. Concrete slab, concrete wall, and then glass and shading devices. So, this is what happens when we're trying to maximize thermal mass heating. The sun's angle is such that we let the sun penetrate, warms up the slab, warms up the wall. The bottom vents, this glass cavity is vented, bottom top. What happens to air when it gets warm? It rises, okay? So by natural, what's the word that defines what air rising?
Convection.
Convection. Very good, Luis. We have natural convection going on in this cavity. As the cavity heats up and the surfaces heat up, we open the bottom vent and it sucks fresh air into that vent. And in the wintertime, we open a vent here and it sends that hot air into the building. Pretty cool. Now we have the next condition, which is when we're trying to keep the building cooler, the angle of the sun's rays are reflected and deflected off of the solar shading devices. It does heat up the external wall, so we have a thermal mass where the air is trapped. And then we bring fresh air into the cavity. By natural convection, the air rises. We open the vent at the top of the wall, and it sucks air from the building into the cavity and flows out. So you open vents on the north side of the building where there's cooler air, and it flows and it sucks as you create a negative pressure through this convection wall, and it sucks the air out of the building, creating a natural ventilation. Pretty cool. And the last one is in the spring and summer, or excuse me, in the spring, we want to trap the cavity, air in the cavity. We want to close the vents and let the warm air buffer against the cold night temperatures, and then these become thermal masses that radiate heat into the building at night, so that in the morning when you come in, you don't have to crank the furnace on quite as high and rely on the mechanical system to heat the building. It's naturally being heated by the radiation from the thermal mass. So, let me get to the financial analysis on that real quick. Okay, here we go. The construction cost of that wall was $185,000. And we assumed that it would contribute about 10% to the overall energy savings of the building. So here's our annual baseline cost, once again about $1.75, 10% of that. Here's our 5-year energy savings, appreciated the value at a 7 cap, $262,000. So here's our cost, here's our savings, here's our increased value, net value gained, 91.9% over 5 years, or an 18.4% return. I'm going through that quickly, but the math is accurate. And it's proven out to be an incredible feature for this building, and the architectural engineering firm, the people that work there love it. It's just cool space, and it's different. It's unique. It's a conversation piece as well as an energy-efficient solution in design. This was an old building at Oregon State University for the engineering department. Basically, they had a budget of $12 million to renovate this entire building, 31,000 square feet, but complete demolition of the interior to create an environmentally sustainable building and a seismic upgrades to allow the continued occupancy of the building. They also wanted to turn, that's what it used to look like. They wanted to turn the building into an exhibit of structure and seismic sustainability. So the interior of the building has a lot of glass showing the structural and mechanical systems of the building. It's really very cool. Sensor controls save about 30% of energy, and we talked about that where rooms aren't occupied, systems go off, systems come on when you walk into the room. 75% of the construction debris was targeted for recycling back into the project. Sustainably harvested wood, operable windows, air quality by minimizing the VOCs, which is, comes out of the tiles, depending on the materials you use for flooring and wall coverings and so forth. It eliminates the VOC penetration of the building. Here's what it looks like now. Renovated structure is a teaching tool for students. It's really a cool study so that the bones of the structure, the bones of the mechanical systems are visible. And this is just a real quick time lapse, if it will work. Sometimes it works, sometimes it doesn't. This time it looks like it's not going to work, which is fine because we're really close to the end anyway. But this is basically, it's kind of a cool time lapse of the total demolition of the interior and then the rebuilding of the building. The future, carbon neutral, net zero buildings, pretty difficult to attain. There's a study being done now. These are some of the things we've already talked about. But there's a study, this is a pretty interesting thing. These beams are called 7 FIRS, and basically it's 7 components built into one system. It's structural, it's mechanical, it's electrical, it's fire sprinkler, it's ventilation chase, it's data and cabling, and it's the finished ceiling, all built in a factory, all brought in and installed. So it's one component covering 7 elements of the building. Pretty cool. Gathering rainwater. This is a model, a graphic model of what the Oregon Sustainability Center, which is going to be the Green Living Building Challenge, net zero from day one, from construction through occupancy, will have zero impact, carbon neutral building on the environment. We'll see if that happens. It is now 6 o'clock. Anybody have any thoughts or questions on what we've covered today? I know the last part of it went a little quick, but there's a lot of material to cover in 5 hours. I appreciate your attention. Once again, applaud you for your efforts of becoming SIORs. So hopefully today you learned a few things about disclosure and ethics this morning, and then this afternoon we increased your vocabulary. I don't want to make you into contractors, architects, and engineers, but you can speak the language, go out there and earn a fee helping a client build a new building. If you do have questions going forward and you're meeting with a client, you just need some feedback or input, call me anytime.